So I want to show you this. Suppose you have two samples from two populations, blue points, red points. Draw some line to separate those points. Like, what can you do? So sometimes you can choose from a lot of lines. So in this example, any line between the two purple lines will do the job, right? But if you further think of it, what line is if you want to build a model, you want just calculate to one result, like which one would you prefer to choose. So one normal way is to think of a way to maximize the distance between the nearest blue points to the separator and the nearest red point to the separator. So if I draw a vertical distance between the first sample to the line and the second sample to the line, maximize this example. So that not only so that this area between not the area, the separation between the two purple lines, or the separation between the purple line and this blue line is higher. And but to do this, you need the formulation of the line, right? You can't just tell the computer this is line, and you have to give it the formula. So to formulate a line, we can use this formula. So this is wx plus b, and so what is xi? So in data science, sometimes we can store an observation xi. So xi is all the parameter of the ith observation. So xi is actually a vector. So in this case, the first term of the vector can be the x value, and the second term the y value. So this is xi. But usually when you think of a line, especially from those high school algebra, we think of this term. So b equals to, for example, b equals to half a plus a half, if b is greater than one, some constant of a plus some other constant, then it's on the top of the line. And if b is smaller than this 1/2a plus 1/2, it is below this top of the line. This line. So how do I put y? It's like y equals to ax plus b. How do I put this form into this form, into this form, right? So basically, you just rearrange the terms. So this would be like 2. So b equals to half a plus a half can be written as like 2b minus a equals to 1. And if you think of that, the coefficient with a is -1, and for b is 2, so we put it into the vector -1, 2 times a bi is 1. So or you could rearrange in this term. So this is your vector w, and this is your feature vector xi. And a is the horizontal value here. Bi is the vertical distance, coordinate of the ith point. But then also now we have this line. Now we need to formulate this. So this is a distance, right? And it's interesting to think of the value of w. So this vector w here is actually perpendicular to this separating surface. In this case, it's a line. In a 3D case, we probably need a plane, but it's a linear surface. So for any v along the surface, so if I draw a little v here, then for any vector of x on the line, the x plus v is also on the surface. So you could easily prove that this is working. And what's more, since this vector is perpendicular, is in this direction, if I take the dot product between the vector from the line and this dot and the nearest point and w, you can get a distance, and but more importantly, a signed distance, which is this. What I mean by that is that this thing is the vertical distance, right? And but then you also need a classification of y. So we put one group of y minus 1 and another 1. Why do we do that? Because this indicates which side the dot is about the plane, and this tells you what type it belongs to. So if the type is 1 and the distance is positive, so on one side you want the product of these two to be greater than 0. So this is greater than 0, this is greater than 0, the whole thing is greater than 0. So that what do I mean by that? So it's so the red dot is in this direction of the line. If it's positive, then all the dots should be in this. So that all the dots have the type. All the dots have the yi greater than 0, and also have the distance greater than 0, which means the distance is to this direction. Whereas in this side, everything is less than 0, and distance and the sign the distance less than 0. So the minus times minus is positive. So if the product is positive, then every point is correctly classified. So this is what we mean by maximizing the classifier. So this is our sign distance. So it's greater or equal to gamma, where gamma is the minimum distance, like sign distance, but it has to be in this case it has to be greater than 0, because you want every point to be correctly specified, at least correctly classified to some distance. So you're maximizing that minimum distance, but this can be some algebraic way converted into this form, and probably just by dividing, the absolute, like the norm of w, which I kind of forgot, but you can do this with some algebraic trick, and then you need to solve this optimization problem, because you want a model, you want a number, right? And from some theorem from optimization, so by calculating the Lagrangian or by the representative theorem, the final result of this problem is in the form of y hat equals to this. So y hat is the predicted value of the new point. So and this x here is the new x. The new x means the new coordinate of the data point. Suppose I have a new point here. This function give you a y hat. Y hat y hat is the value whether this is belongs to the group of red point or belongs to a group of blue points.